Okay, so the way I'm going to go about doing this video is I'm going to look at the grading document and then go down the list and explain each feature. Okay, so the first thing that's on the list is entities, and the first one is the blaster out of all the entities. So right now I'll show the attractor mode. Oops, I'm sorry. Without all the other information, I'll just do the blaster itself. So this is the attractor mode blaster. As you can see, it's just a parameter integer passed into creating a blaster. And depending on the integer, it'll either be a blaster or a keyboard controller. So that's the attractor mode. And then I'll show you the keyboard mode. So as you can see, there's no movement, but if I move the left, left, right, right, down, down, up, and spacebar, I can shoot. And there's only one bullet allowed. And the way I did all this was basically in the blaster, it has a strategy pattern and it's composed with a controller class. And basically it has the current controller, so the controller that is being used, and then it has two defining controllers. So it says which was the keyboard commands and which one's the AI commands. And also we have this blaster bullet called bullet fired. Basically all it does is if you press space with the player controller, it will create a bullet if there's not already a bullet in the scene. So if that bullet reference is not, if it's null, then create one. The way the AI controller and the blaster controller works is in the actual blaster in the update, it just calls the strategy's movement command. It just move, and in each one of the controllers it has a move, as you can see here. And basically in the attractor, it'll fire a bullet, it'll keep continuously firing a bullet, and then if it can move, because there's two alarms, one is for actually moving and one is for staying in place, but it'll always keep firing. So if that queue is empty, then it has to make a decision where to go, and that is based on a random, the direction of the Y and the direction X. So here, if it's on top border, then the direction is going to be down. If it's on the bottom, it's going to be up. And here's the random direction X. So all it does is basically adds a diagonal queue to that current queue. And basically, if that queue is not empty, it'll process that first offset. So right here you can see the position, and right here I have it clamping just to make sure that it doesn't go past the borders at any point. And then after it's done processing, just pop that queue. Here are the alarms, and in the actual keyboard one, you have all the keyboard commands. So if it's left, then it'll go left. If you press up, it'll go up, down, down, right, right, and so on. And if you press space, the blast is controlled. So that's pretty much it. I have to show the sounds, which you've already heard the blaster, but now I have to show the death. So I'll just initiate the actual full game mode and then just die in it to show you the explosion works, and yeah, all the other things work. And every single object that is being destroyed and then recreated has its own factor. So there's the death and the explosion. But just to show you that it does have, there's the recycling bullet factory and the blaster factory. Just reuses the objects, but all the factories are basically essentially the same. That's pretty much it for the blaster. Okay, so the next thing we had to do was the mushrooms, and that includes the 4 lives, poison stain, regeneration, and the sound whenever it gets destroyed. And right now I just have it set to being the same starting number of mushrooms. So I've disabled all collision just for showing the mushrooms. So as you can see, the scorpion actually poisons the mushroom, so it has that poison state. And when I shoot it, it'll actually go to the next frame of the sprite, showing that there's damage. So there you go. And those poison ones work the same way, where if I shoot a poison one, it'll also degrade its health and its status. The mushroom field itself is working, as you can see. All of the centipedes and stuff are interacting with it. I'll show how the mushrooms and the fields work in terms of the overall game, so how it changes between players too. So first of all, each player, which is right here, I have the player 1 and 2, and then player 0 is the attractor mode player. So basically it creates a new mushroom field, and then it initializes that mushroom field, and what that does is just randomizes the field it has. But first I'll talk about the mushrooms themselves. So the mushroom has a state called is poison, and that just basically determines if a mushroom is poison or not. And when the scorpion is actually over the spider, when the scorpion's over a mushroom, it'll call upon a function called poison, and all that does is sets the visual sprite of the start of it as the first one, or not the first one. It depends on the max HP, but the start of the poison is on the fourth one, and then it'll set the is poison to true, and that way when the scorpion goes over it and it checks to see if it's on a mushroom, it'll call that poison, and then it'll set the mushroom to poison as you saw in the video. And the 4 lives is pretty easy. There's just an integer that says the maximum HP, which is 4, and then another integer which is the current HP. That way when the bullet collides with the mushroom, it'll just it'll subtract from the HP. If it's poisoned, it'll set the frame via poison. If it's not, then it's regular, and set it to the regular first 4 sprites. So that way it keeps track of if it's poison or not when you shoot it. And then if it's the HP is less than 2, which means if it's 1, then this collision will destroy it. So then add the current score, which is 1, and then destroy the mushroom, which is a grid position. After this video, I'll get rid of this constant right now. For the other ones, I have constant numbers for the score, but keep in mind this will be changed right after the video. And the mushroom field itself, when you initialize it, it has 2 fields basically. The first field is a Boolean field, a Boolean multidimensional array, and one that has mushroom pointers. One of them keeps track of the actual physical field, so the things that the player is seeing. But once it changes players, then we need to keep that. And the way I did that was I have a Boolean state field, which is just a multidimensional array that keeps track of the mushrooms on the field, so that when a player dies and it switches to the other player, you can clear the physical mushroom field but still keep the state of it. And I did it this way because writing to disk is a lot more expensive on the computer, so I figured sacrificing a little bit of memory for this would be a lot better. And so here we have clearing and respawning the field. That's what I was talking about. Clearing the field, all it does is removes the physical field but not the state of the field. So as you can see, it calls field but not state. Respawning the field, so after it's been cleared and the new player's up, it'll respawn its field based on the state. So if when it died it had a mushroom there, and if there's not a mushroom there already, just to make sure for the checks, then create a mushroom there. And that's how switching between one player and the other player works with the mushroom field. In each player, each player has its own field. So the attractor mode has its own field. In my case, player 1 has its field and player 2 has its own field. And when he creates a field, it'll initialize that field, and it'll just start the random thing. And that's whenever you switch modes, it'll initialize each player's field. So the next thing we have is each player respawns its own field, etc. But that respawning happens again when a player changes mode. The player changes. That's it. And I think that's pretty much it for the mushroom field. So the next thing we had to do was the centipedes, which was basic sounds, movements, death, smooth 180-degree turn, stays at the bottom row, splits when the second hits, and it drops to the bottom and hits poison mushroom. So I'll just show that in real time in the game. So as you can see, the centipede does turn, and it will go all the way to the bottom, but right now I'll show the splitting in action. So there you go, I split it. That's functioning, it's keeping the order. And once it goes to the bottom, it'll actually stay with the bottom, and it'll spawn the heads, just like in the original game, because I added that as a feature. But as you can see, it stays within the bottom, and it does ignore the mushroom at the bottom once it turns. So that's it for the turning. As you can see, it has 180 degrees, and ignores that mushroom. It stays in the bottom rows, and it does split when the segments hit. The next thing would be actually showing you the poison mushroom movement. The mushroom, when it's poisoned, causes the centipede to actually drop all the way to the bottom. So as you can see, here comes the scorpion to lay a poison mushroom down. And here it goes. As you can see, it goes all the way down, turning until it reaches the bottom. And now I'll show how I actually did all the centipede stuff. So the first thing I'm going to do right now is just show the individual heads factories. So as you can see, they're all singletons. All of my factories are singletons because there's only one needed, and a global access was a good idea. The one difference I made for this factory, it's really more an assembler factory, an assembly. So basically, it's called centipede factory, and what that is, it just connects each individual parts into one centipede. And one important thing about this is it keeps a list of all the centipedes that are currently alive. So as you can see, it's a singleton too, but what this actually does is when you call create centipede, it'll create an actual centipede of more than just one segment, as opposed to just creating a single head or single body. But what it does is it first creates a head and then links more bodies to that head. And basically, if I have a size 8, it'll create the head, and then 1 minus the size, so 7. So it'll connect 7 bodies to make an entire 8. And this is really important because this stops my previous problem of when I collided my blaster bullet with the mushroom and I tried to split it, it would create an offset. And that's because the head was picking up the previous bodies, or the following bodies, position, but it was a previous position of that because the actual position did not update on that frame. So what I ended up doing was making the head be the last one to be updated, and all the following segments are updated before its previous one, so that way when it collides with something, it'll get the correct position. And like I said before, I keep a list of what's alive, so whenever a segment is destroyed, it'll deregister itself from the alive segments. So this would technically be the observer pattern, because it keeps a collection of objects that are alive, but whenever it's dead, it'll send back a signal to the alive segments to deregister itself from the alive segments. And what this does is it removes that segment. So when I pass in an object, a centipede segment, to be destroyed, it'll check this for pointer equality, which just means that the same object, so destroy that object from the list. And then I have also add a live segment. This is the registering to be in the actual list of being alive. and that's done with the centipede heads. So if you look at a factory, it adds that head. The same thing for the body, but it registers it to the actual list. And then this is important, the recall all segments. All it does is basically destroys everything that's alive, and that was needed for when you die and you need to remove all the centipede segments from the screen. And that's pretty much it for this, how to manage the alive mushrooms. But now I'm going to talk about the centipede head segment itself. So the centipede head segment is the only one that's actually doing any decision making. And what I've done is whenever a head is created, it pre-computes what a turn is and what a horizontal is based on the speed. And I did it on creation because when it's initialized, because when it's initialized, it will be at different speeds, because the first wave could be speed of 2 and the next wave could be speed of 4. So that's why I did that. But the overall decision making process of the head is in 2 parts. If its current queue is empty or not empty. So if it's empty, that means its previous job has been done, so now it has to make a decision on what to do next. And the first thing is if it's poison state. If it's in a poison state, it'll just keep doing turn queues until it's not poisoned, which is where this block of code comes in. This just checks to see if it's at the bottom of the bottom border, so the very bottom of the screen. If it's true, then has touched bottom equals true, and is poison state equals false. And that's because the centipede will keep turning until it hits the bottom, and this is where to set it to false. And another thing is, this is what controls the spawning of the little heads at the bottom once the main, once a centipede head reaches the bottom. Just like the Atari game, which I wasn't sure if you were supposed to input or not, but I did it anyway, just for the consistency of trying to make it as close as possible to the original. And then if it's not poisoned, it checks to see if it's on the edges of the screen. If it is, then just turn. And then it checks to see if it is the next cell is a poison mushroom. If it is, then that means you turn and you set poison to true, and that's where the poison state comes in. It'll keep turning and turning and turning. Then it checks to see if there's a regular mushroom in the field. If there is, then just turn. If none of those happen, then it's just a horizontal movement, so it does a horizontal movement. And if the current queue is not empty, that means it still has to process some sort of movement, so that's what this does. And then again, when you destroy, you deregister it from the alive list. And also, if the number of instances, which is a static number, it just keeps track of the instances of the actual centipede heads. If the number of instances is 0, then you can stop the centipede sound. And then when it collides with a bullet, it'll check to see the alive segments. It'll check to see if that's equal to 1, because if it is, that means this collision is the only segment that's left. And then after this collision happens, there will be none left. So that means that a player has won the wave. So it'll increment the wave, it'll stop the spawning of the heads, so that the next wave, when the centipede touches the ground, that's when it'll start spawning again. And then you load the player wave, which is the new wave due to the incrementing. So next wave. And it'll add the current score, which is the value of the head. It's a constant integer. And then it creates the mushroom field. Not mushroom field. It'll create a mushroom at the spot of death. One in front of the spot of the death. And then it'll proceed to creating a head and replacing the following segment with that head, setting the current queue of that head to the queue that it's replacing, and then just link it accordingly. Mark the first body, which is the one that's being replaced, and then again you update the update list accordingly to avoid that offset position on collision. And then I'll show you the centipede body segment. Very, very similar in terms of collision, but the main difference is the decision making. The body does not actually make any decisions. What it does is when the queue is empty, it'll get the future queue, which is the cue passed by the head segment whenever it moves. So if you can, as you can see here, it'll push what it just did to the following segment. So it creates a hierarchy of I did this, and then I send it back, and then that mushroom, when it's done with its current cue, it sends to the previous one, and so on and so forth. And if it's not cue, it'll just process that movement. That's pretty much it for the movement of the body segments. It has almost the exact same thing for the collisions. I think it pretty much is, so I don't need to explain that. Yeah, that's pretty much it. So the Centipede does have the basic sounds as I've shown you. It does have the movement. It does have the death, as I showed you when I shot it. It does have the smooth 180 turns, stays at the bottom, splits when the segment is hit, and then drops to the bottom and hits when there's a poison mushroom. And that's pretty much it for the Centipede segment, or the Centipede in general. So the next thing we're supposed to do is the Scorpion. I've already shown you that it poisons mushrooms, but I'll show you again. We had the basic sounds, movements, and the death. So as you can see, the movement works. It does poison the mushrooms. And the next thing, I'll just destroy it very quickly just to show. There you go. Registered the points, the player explosion, the enemy explosion happened, and that's pretty much all that the Scorpion does. It's pretty simple. So again, the Scorpion has a factory, which is a singleton. Very basic, similar to the other ones. And what the Scorpion does is basically, it has a horizontal cue. The Scorpion speed does not change from my knowledge, so in the construction I basically pre-computed that horizontal motion, and that's based on the speed. You can change the speed if you wanted to, but for now it's just a constant integer. It gets the cell, divides it by the speed, and then puts in as many of those speed inputs it needs to achieve the mushroom cell segment complete movement. So again, similar to the Centipede, it has a current cue, and basically if it's empty it'll decide what move to do, but since there is only one move, just moving horizontally, it'll set that horizontal. And then because it's empty, it means it's in the middle of a cell, and it'll check that cell to see if there's a mushroom in there. If it is, then it'll poison that mushroom, and poison is just a method that sets the boolean is poison to true, which I've shown you in the mushroom video. And if it's not empty, then it'll just process and it'll move forward, or depending on the direction. And this is all Wave Manager stuff, which I will explain later. And the Sound Manager just stops the Scorpion sound on destruction. Scorpion, whenever it's initialized, it'll play that Scorpion sound, not in the constructor, because then it will play that same sound twice in the same instance, because both get called when a new segment is created, but initialize always happens. So then on the collision of the blaster bullet, it'll just add to the current player's score, and it'll just create an explosion. And I think that's pretty much it for the Scorpion. There's not much to it. That's all it does. Yeah. Okay, so the next thing we had to talk about was the Flea, having the basic sounds, movement, and the death. It has 2 HP, where it drops faster and stops spawning mushroom after the first hit. So I'll just go to the actual game and I'll show that. So the threshold is 3 mushrooms for the first level, just for demonstration purposes. So if I make it less than 3, it'll spawn a Flea. And there you go, it'll spawn the Flea. And as you can see, it does spawning randomly. So I'll bring it out again and I'll shoot it. Bring it out again and I'll shoot it just to show that it does go faster. There you go. It went faster. And as you can see, it works. And it'll keep spawning until it reaches that threshold. So it stopped at 3. The way I did it, it's pretty simple. So basically I pre-compute those movements. Either it'll go down or the second downward speed, which is basically, if you look at the H file, there's two queues, the downward queue and the second speed downward queue. And then there's two speeds, the speed and then initial speed, and then the speed after being hit. This second speed multiplier just multiplies the initial speed to get this second speed after being hit. So when it computes the downward positions, it'll get the regular speed or the speed after being hit, and it puts it into those queues correspondingly. So if the current queue is empty, it'll make a decision where if it can spawn mushrooms, and can spawn mushrooms is basically just a boolean that is flipped on collision with a blaster bullet, because once you hit that blaster bullet, then it will stop spawning mushrooms and it will do the second speed. So here we go. It creates a mushroom based on random chance, and if there's not already a mushroom there, and then if it can spawn mushrooms, that means that it has to do the first speed, but if it doesn't, then it does the second speed. And then if the current queue is not empty, then it'll process the next offset and then pop it. So when it's destroyed, it sets the flee to dead, which is in the wave manager. It's a reference to the flee, and the wave manager will actually call the field. So wave manager, it says set flee to dead. So as you can see, when I set the flee to dead, it'll basically just say is there a flee in the scene, and flee is in a scene, and that's just checks for whenever it has to create a flee. If it does, then it won't create one. But basically the way that the flee is destroyed is in the update. If it's past the viewing area, then it'll mark this flee for destroy. And then of course when you destroy, it'll call upon set flee to dead, which then sets if there's a flee on the scene, null, and then sets it to, if it's in the scene, to false, and flee on scene to null. So then it checks to see if it should spawn another flee. So when it's destroyed, if there's still less amount on there, so if it's destroyed by the blaster or if it's destroyed due to going out of the screen, it'll check to see if it has to spawn a flee. And basically that's how it works. When it initializes, it'll play the flee sound. Hopefully the sound hasn't been distorted or lagged. Sometimes that happens with recording software. But the way the blaster, the movement works for second, is when it hits the blaster, if the HP is not going to be 0 after this one, so if the HP is 1, it'll add to the current player score, and then it'll create that explosion, and it'll destroy this flee. If not, then it'll set can spawn mushrooms to false because it's hit it, and then the HP gets lower. That's what happens here on this update. If it can spawn mushrooms, it'll do the downward queue. If not, then it'll do the second speed queue. And that's basically it. I got the basic sounds, movement, and I'll show you the death since I forgot to do that, but it does have the 2 lives. So I'll spawn the flea, and then I'll just kill it. There you go. That's pretty much it for the flea. So the next entity we had to do was the spider. We had to have the basic sounds, movement, and death, and then score on death based on the distance. So I'll show it in action, even though you've probably seen it, but now it's focusing on the spider. So as you can see, it does move. It does move in that random pattern, and then it does respond to the wave manager. And right now you can see that if it goes over a mushroom, it'll die. The mushroom will be destroyed. There you go again. And then based on the movement, so that was one score. Oops. So 900 if I'm very close. And then if it's very far, I should get that 300. And if it's in a medium score, I will get around 600, which is right there. And it does report it the way you want it to, so it does have the basic sounds, the movement, the correct movement, and then the depth, because the movement, it starts going right and keeps going right until the edge of the screen, and if it's going left, it'll do the same. So now I'll talk about how I actually did that. And if we look at the spider, there's a factory, of course. Again, singleton for global access, and because we only have one. I'm sorry, my voice is going a bit, but the way it works is it has a pre-computed diagonal queue and a downward queue. And basically, a downward queue is one cell movement. So it'll move one cell, and the diagonal queue is one cell too. And the reason I made them one cell is because I wanted a collection of these to dictate what a movement is. So if I move diagonally to the right, it could be made out of 5 one cell diagonal movements. And that's what I wanted, because that creates a random length that I'm going diagonally or downward, just like the game, because it does change midway too. So let's say if it goes diagonally 2, at that end it could go 3 diagonally or down. So the way it basically works is, first of all, I check to see if the spider is out of the viewing area for precision. If it is, then destroy this one. And the wave manager sets a spider alarm, which basically just triggers getting another spawn time, because if you actually destroy the spider in the game, it'll come up 4 seconds after, and it seems to always be that way. The only time difference for spawning that actually happens is when it goes out of the screen, and that's a completely different thing. So this is the one that's actually out of the screen, which is random, not random, well, kind of random, but it has that wave settings spawn time. So spider spawn time for 1. So at the edge of, when it reaches past the edge, it'll spawn in 1 second after. Then it checks to see if the current queue is empty. If it is, then that means we have to make a decision. So if it's at the top border or the bottom border, then if it's at the top border, it'll go down, and if it's at the bottom border, the direction goes up. And then you choose a random direction, which is right here. If it's up, if it's 0, then it goes up. If it's not, then it goes down. This whole thing is dictating what the direction is. So if it's at any of the borders, then it'll change this for sure, the direction 1 or -1. If it's not at the borders, then it'll choose a random direction. And this is for the choice of either going downward or diagonal. And this number of moves is the number of little cell segments it will actually put in. So right now it's from 0 to 3 plus 3. So it'll be 3 minimum or 6 maximum. So if the choice is equal to 0, downward, then it'll push those number of moves into the down and the queue. So the overall queue itself is a queue of queue. So it's one entire movement, so like a movement of 3 diagonal, that's made up of another queue which is just 1 cell movements. The reason I did this is because I wanted to be able to check at every cell movement to see if I'm hitting a border or a mushroom to see if I have to eat a mushroom. And then I also wanted the overall movement, which is made up of the cells, in order to see if I've completed that movement and if I have to change what it is. The cell ones dictate if I'm at the border. Then at that point I change cells too. So again, if it's not empty, so if the whole move is not empty, it will check to see if this current cell is at the borders, and if it is, then it empties the current queue and sets is on the border. That way it just immediately causes a new decision, and because it's already at the border, it'll cause that decision to be downwards if it's at the top, or upwards if it's at the bottom. And then if this is not happening, if it's not at the border, then it'll do the next cell movement, and then it gets processed. And then if the current queue is empty, then it'll set the border to false, and it'll check to see if there's a mushroom that it can eat. And if it is, it'll destroy it, and then it'll pop that queue. So the destroying, basically, the spider only has a sound once it's actually in the game. So when it's initialized, it starts the sound. When it's destroyed, it stops it. And then the same way I did the flea, it sets the spider to dead, so that the wave manager can check that reference to see if there's already something on there, and it'll prevent the spider from spawning. If during a transition from one wave to the next there's already spider, the spider does not actually get destroyed. And this is where the score is actually done. It's the blaster bullet and the spider. So basically the blaster bullet already has a reference to the blaster because of the observer pattern, where the blaster signals the blaster bullet signals to the blaster that it's dead. So basically I did the Pythagorean theorem, where I got that bullet's shooter's position, and then the position of the spider. So that's computed as the distance apart. So if the distance apart is less than or greater than the close distance, which is that 900 score, if you look at the H file, I have all these scores as being constant, and even the distances. There's only close and medium, because the far distance is anything above the 100. So first it checks to see if it's close, then medium, and then else is the far proximity, and it'll add the score based on that value. I'll talk more about the player manager, because that actually adds to the current player score. So when the player is killed, it'll cause another one to spawn in the time between the spider and death, and that's the one that's 4 seconds whenever you destroy that spider. And then it'll create the enemy explosion, and that's pretty much it for the spider. It was pretty complex, but after the centipede it was pretty easy once you understand the queue system. And that's pretty much all of the entities, I believe. The next thing I'll talk about is the actual game modes and the scoring and the wave manager. First I'll talk about the wave manager. So the next thing that it seems appropriate to talk about at this point is the wave manager, which basically just switches from one wave to the next wave. It also loads a text file once to get all the parameters for a wave, which includes the centipede, speed, length, head number, etc., and timers. And we had to make it in a text file that was user friendly. So now first I'll show you the actual text file. So the wave settings is basically a 2-column setup. It's basically the variable and then the value we want for that. So these are obviously booleans, and false, false. This dictates this marking, the double / is tell when a wave is done. This is which wave, but it's just a placeholder. So as you can see, I have the 10 waves, And the way that it's loaded is if you look at the wave manager, right here. This is the loading the wave information. This is called only once, which is at the beginning at the level 1, at the beginning of the scene level. So as you can see, it's loaded once. It loads high scores, which is different, but this loads the wave information. So as you can see, it basically has two strings: the identifier, which is the first column, and then the value, which is the second column. It opens the F stream for input, and then if it's open successfully, then do the actual parsing. Else, write could not open file. So basically, it grabs the first two tokens, it gets the current identifier and then the value, and it places them in the corresponding strings, and then it converts the identifier to lowercase just so that it doesn't matter what they put in, and then it checks to see if the identifier is centipede speed, and then add its value accordingly based on what type it is. So this is string to integer, string to float, and then the boolean. So it basically checks the value to see if it's equal to true or false, and then sets that to its corresponding thing. And I've created another class called the wave definition, which just basically holds what each wave is. So we have the centipede, speed, length, head, etc., etc. And it adds it to temp. And temp is actually just a wave definition, as you can see, for each line. And then it adds it to a vector too. And the reason, the reason I made it a vector is because I wanted to have that indexing capability, but I also wanted to have the ability to push to the back, because the way I have it set up right now is you can actually add as many waves as you want just by accessing that text file. And it also doesn't matter if you're missing a variable or something for a wave. It'll just get the default value, which is right here based on these wave definition constructor, and it loads that. So basically what it does is it gets that file and loads each vector position depending on how many waves there are with a wave definition, and that's basically how it loads it. So next I'll show that the wave manager actually does go from one wave to the next. And to do that, I'll actually simplify the first length to just having one, so I can just immediately go to the next one. So the first wave should be just one head with the spider and no fleas or scorpions. So there you go. And the next one should be, I think, a length of 11 and one single head. Or 12. So I'll destroy this head. And there you go. So it's a length of 11 and then the that one single head. And this is the first level, so the second level, so there shouldn't be any. There should be a flea actually, and I think the length is 4, so there you go. The threshold is 4. So if I do it again, it'll spawn another flea. The scorpion does not come out until the actual 4th wave, I believe. So I'll get to the 4th wave. So the way I have it set up and the way it seems to be in the game is that every 14 seconds a scorpion will come out. After the video I'll check again and tweak it, but I think that's how it goes. So there's the scorpion, and it's going to the left, and so that's showing that the waves do transition from one to the other. And I use only player 1 mode, because player 2 mode is essentially the same, but I'll talk about that later once I get to actually talking about game modes. For now I'm just showing the functionality of the wave manager itself. So the way it works is